Hello, my dear students. Good morning to all. I am Sravani, Assistant Professor in CSE Department, Mlritm College, Dundigal. Today, we are going to learn conversion from NFA to DFA. So, in this session, we will discuss the method of converting NFA to DFA. So, before conversion from NFA to DFA, just what is DFA? What is NFA, what is the relation between these two, and what is the difference between these two. First, in NFA, NFA stands for non-deterministic finite automata. In this, in NFA, it consists of, it can be represented as 5 tuples. Q, sigma, delta, Q naught, F, where Q indicates set of states. Q indicates set of states. Sigma indicates set of input symbols. Set of input symbols. Delta indicates transition function or mapping function. Delta indicates transition function or mapping function. Q naught indicates initial state. Q naught indicate initial state. F indicates final state. NFA can be represented as 5 tuples: Q, sigma, delta, Q naught and F. Q indicates set of states. Sigma indicates set of input symbols. Delta indicates mapping function or transition function. Q naught indicate initial state. F indicates final state. That is formal definition of NFA. In NFA, when a specific input is given to the current state, that means we are consider one example. Let us consider this transition diagram. So, in NFA, when a specific input is given to the current state, let us consider my current state is Q naught. In this example, total how many states? Q naught, Q1, Q2, 3 states. Initial state is Q naught, final state is Q2. Q1 is intermediate state. Input symbols are 0, 1. So, these are the input symbols. Let us consider in NFA, when a specific input is given to the current state, that means Q naught of 0, that means current state is Q naught. Q naught of 0, it goes to Q1. So, the machine goes to multiple states. That means here delta of Q naught of 0. Q naught of 0, it goes to first Q naught. Again, delta of Q naught of 0, it goes to Q1. That means Q naught of 0, it goes to Q naught and Q1. That means machine goes to multiple states. It can have 0 or more than 1 moves on a given input symbol. That means let us consider here in this Q1 of 0, it goes to Q2. But in Q1 of 1, there is no next state. In NFA, may or may not contains next state. It contains 0 or more than 1 move for a given input symbols. That is NFA. In case of DFA, DFA is also contains 5 tuples. DFA also contains 5 tuples. Q, sigma, delta, Q naught and F. DFA consists of how many tuples? 5 tuples. Q, sigma, delta, Q naught and F. Q indicate set of states. Sigma indicates set of input symbols. Delta indicates mapping function or transition function. Q naught indicate initial state. F indicate set of final state. Same as NFA. What is the difference here in DFA? Let us consider one example. Q naught, Q1, Q2, 0, 1, 0, 1, 0, 0. In this example, when a specific input is given to the current state, that means Q naught of 0, input is either 0 or 1, but we are consider Q naught of 0, that means specific input is 0. Specific input is given to the current state is here Q naught. Q naught of 0, it goes to Q1. Ante that means machine goes only one next state. But in case of NFA, it goes multiple state. That is the main difference. That means here sigma delta indicates Q into sigma tends to Q only. That means Q indicates in state, sigma indicate input symbol. It goes to only one next state in DFA. But in case of NFA, mapping function are Q into sigma tends to 2 power Q. 2 power Q is nothing but it goes multiple states. Okay. So that is the main difference. Simply NFA has multiple next states. In DFA having only one next state. Okay. Next, here this is M equal to Q sigma delta Q naught and F. This is DFA representation. That is NFA representation. Is an NFA accepts the language L of M. L indicates language. Already last class I am saying that language is nothing but collection of appropriate string is called as language. So here our concept is conversion from NFA to DFA. So NFA can be represented by represented as 5 tuple Q, sigma, delta, Q naught and F. That accepts the language L of M. Next, there should be an equivalent DFA which is denoted by M dash. M is nothing but NFA. M dash is nothing but DFA. DFA is also contains 5 tuples Q, sigma, delta and Q naught. So such that language is represented by L of M dash. L indicates language. M dash indicates DFA representations. Right? So our concept is conversion from NFA to DFA. So these are the steps to follow convert NFA to DFA. Total how many steps we are following? 4 steps. Step 1, initially Q dash equal to 5. So consider this example. So example 1 is convert the given NFA to DFA. So here total number of states are Q naught, Q1, Q2, right? Sigma, input symbols are 0, 1. Mapping functions are Q naught of 0. Q naught of 0, it goes to Q naught. It moves to Q naught. Next, delta of Q naught of 1. Q naught of 1, it moves to Q1, right? Next, delta of Q1 of 0. Q1 of 0 equal to Q1 of 0, it moves to Q1 and Q1 of 0, it moves to Q2, right? Next, delta of Q1 of 1. Q1 of 1, it moves to Q1. Next, delta of Q2 of 0. Q2 of 0, it moves to Q2. Next, delta of Q2 of 1, it moves to Q2 and also it moves to Q1. That means Q1 union Q2. That means Q1 comma Q2. These are the mapping function. Next, initial state equal to, initial state is Q0. Final state is here Q2. These are the NFA representation. Let us consider this example to convert NFA to DFA. How to say that this example is NFA? That means already I told you, right? So, one input symbol having more than one next state. That means here Q1 of 0, it goes to Q1 and also Q2. So consider this one, delta of Q2 of 1, it goes to Q1 comma Q2. So this is the correct example to convert NFA to DFA. So before converting from NFA to DFA, construct NFA table for the following transition diagram. First, draw NFA transition table. First, draw NFA transition table. Transition table contains how many fields? States, input symbols. So, first one is states, second one is input symbol. In this example, input symbols are 0, 1. Input symbols are 0. Next one is 1. Total how many states in this example? 3 states. Q0, Q1, Q2. Write down that one. Q0, Q1, Q2. Here initial state is Q0. Final state can be represented as either circle or star. Okay, right? Next, Q0 of 0. So, Q0 of 0, it moves to Q1. So, Q0 of 0, it moves to Q1, right? Next, Q0 of 0, it moves to Q0. Next, Q0 of 1, it moves to Q1. Right? Next, Q1 of 0, it moves to Q1 and also it moves to Q2. Q1 comma Q2. Next, Q1 of 1, it moves to Q1. Next, Q2 of 0, it moves to Q2. Next, Q2 of 1, it moves to Q2 and also Q1. That means Q1 comma Q2. Mapping function can be written delta of Q1 of 0. Q1 of 0 is Q1. Next, delta of Q1 of 0. It moves to Q2. How it can be write? Delta of Q1 of 0 union delta of Q1 of 0. That means Q1 comma Q1 union Q2. That means Q1 comma Q2. This is the mapping function for NFA. Okay. This is the transition table for NFA diagram, transition diagram. So, before converting NFA to DFA, first construct NFA transition table. Transition table consists of 2 fields. First one is state, second one is input symbols. Inputs in this example, input symbols are either 0 or 1. Here 0, 1. So, first one is here Q0 of 0. Q0 of 0, it goes to Q0. Next, Q0 of 1, it moves to Q1. So, it moves to Q1, right? Next, Q1 of 0, it moves to Q1, union, Q1, union. Q1 of 0, it moves to Q2. Q1 union Q2 means Q1 comma Q2. So, here Q1 comma Q2. Next, Q1 of 1. Q1 of 1, it moves to Q1 only. So, Q1, right? Next, Q2. Q2 of 0 is Q2 only. So here Q2. Next, Q2 of 1, it moves to Q2 and also Q1. So Q1 comma Q2, right? So this is the NFA transition table. So now our concept is conversion from NFA to DFA. So NFA to DFA. So step 1, initially Q dash equal to 5. That means Q dash is nothing but DFA states. Q indicates NFA states. Q dash indicates DFA states, right? So our concept is NFA to DFA, right? Already we are constructing transition table for NFA. But our motto is conversion from NFA to DFA. So step 1 is initially DFA states are null states. 5, that means null states. That is the step 1. So next, step 2, add Q naught of NFA to Q dash. So add Q naught of NFA to Q dash means, so here in this NFA transition table, consider initial state as DFA initial states. So this is the Q naught initial state. Consider, so add Q naught of NFA to Q dash. That means, so this Q naught is added to DFA transition table. So Q naught of 0, it moves to Q naught, right? Next, Q naught of 1, it moves to Q1. So that is the step 2. Add Q naught of NFA to Q dash. Next, then find the transition from this start state. So Q naught of 0 is Q naught. Q naught of 1 is Q1. Next state is, here Q naught is already there. Already a state undi. Next, consider next state is new state of DFA table. So next state is Q1. So write down delta of Q1 of input symbol is 0. So check that. Q1 of 0 is Q1 comma Q2. So Q1 comma Q2. Okay, right? So delta of Q1 of 0 is Q1 comma Q2. Next, Q1 of 1, delta of Q1 of 1 equal to Q1, right? So Q1 of 0 is Q1 comma Q2. Q1 of 1 is Q1. Next which is new state. So this is Q1 is already over, right? Q1 comma Q2 is not there. So here Q1 comma Q2 is next upcoming state. So here delta of Q1 comma Q2, delta dash of Q1 comma Q2. How to write this one? Delta dash of Q1 comma 0 union delta dash of Q1 comma Q2 comma 0. That means Q1 of 0. Q1 of 0 is Q1 comma Q2 union Q2 of 0. Q2 of 0 is Q2. Q2 of 0 is Q2. That means Q1 comma Q2. So Q1 comma Q2. Next, Q1 Q2 of 1. Q1 Q2 of 1 is delta of Q1 comma Q2. How to write this one? Delta dash of Q1 of 1 union delta dash of Q1 comma Q2 comma 1. So Q1 of 1 is Q1 union Q2 of 1. Q2 of 1 is Q1 comma Q2. Q1 comma Q2. So Q1 union Q2 equal to Q1 comma Q2. So this is the DFA transition table. So here in this DFA, Q0 is initial state. What about final state? How to find out final state? So check this one. In NFA transition table, transition diagram, final state is Q2. How to know final state? Double circle represented as final state. So in this example, Q2 is our final state, right? So here in this Q2 ekkadekada undandi? So this is final state. Here also this one is also final state. So this is the DFA transition table. Next, convert this transition table into transition diagram. So total how many states? Q0, Q1, Q2 and Q1 comma Q2. So Q0, Q1, Q2, Q1 comma Q2. So Q0 of 0, it goes to Q1, Q0. It goes to Q0. Next, Q0 of 1, it goes to Q1. It goes to Q1, right? Next, Q1 of 0, it goes to Q1 comma Q2. Q1 of 0, it goes to Q1 comma Q2. Next, Q1 of 1, it goes to Q1. It goes to Q1, right? Next, Q1, Q2 of 0, it goes to self loop, right? Next, Q1 of Q2 of 1 is, it goes to Q1 comma Q2. That means 0 comma 1 self loop. This is the conversion from NFA to DFA. Consider another example to convert the NFA to DFA. So this is the next second example from convert NFA to DFA. So before conversion of NFA to DFA, step 1 is before conversion of NFA to DFA, construct NFA transition table. So NFA transition table. Right? So states, input symbols are 0 comma 1. States are only two states, Q0 and Q1. Q0, Q1. Q0 is initial state, Q1 is final states, right? So Q0 of 0, it moves either 0 or 1. So Q0 of 0, delta of Q0 of 0, it moves to Q0. Delta of Q0 of 0, it moves to Q1. That means Q0 union Q1. Q0 union Q1 means Q0 comma Q1. Next, Q0 of 1, it moves to Q1. It moves to Q1, right? Next, Q1 of 0. Q1 of 0 is null set. There is no move. Okay, right? Next, Q1 of 1, it moves to Q1 and also Q0. That means Q0 comma Q1, right? This is the NFA transition table. So step 1, before conversion from NFA to DFA, first construct NFA transition table. This is our transition table. Q0 of 0, it moves to Q0 comma Q1, right? Q0 of 1, it moves to Q1. Next, Q1 of 0, it moves to null set 5. Next, Q1 of 1, it moves to Q0 comma Q1. This is the NFA transition table. Next, add initial state of NFA to DFA transition table. That means NFA lo initial state entandi, so Q0. That state is added to DFA transition table. So this is DFA transition table, right? So Q0. So in previous Q0 of 0, it goes to Q0 and Q1, right? Next, Q0 of 1, it moves to Q1, right? So next state is Q0 comma Q1. So these two are next newly generated states. Consider either Q0 comma Q1 or Q1. We are consider any one. So first consider Q1, right? So Q1 of 0 is null set. So Q1 of 0 is null set. Next, Q1 of 1 is Q0 comma Q1. Q1 of 1 is Q0 comma Q1. Next, Q1 is already over. Next, consider Q0 comma Q1. Q0 comma Q1 is next state of DFA. So here two states. So delta dash of Q0 of 0 union delta dash of Q1 of Q0 of 0. Sorry, Q1 of 0. That means Q0 of 0. So Q0 of 0 is Q0 comma Q1 union delta dash of Q1 of 0. Delta dash of Q1 of 0 is null set. That means Q0 comma Q1. So Q0 comma Q1. Next, Q0 Q1 of 1. How to write? Delta dash of Q0 of 1 union delta dash of Q1 of 1. Q0 of 1. Q0 of 1 is Q1 union delta dash of Q1 of 1. Q1 of 1 is Q0 comma Q1. So Q0 comma Q1 is Q0 of Q1 of 1. So this is the DFA transition table. So observe any other next state 5. That means we are not consider null state as next state. Q0 Q1 is already over. So Q0 Q1 already over. Q0 Q1 is already over. There is no other next state. So in this DFA, which one is final state? So observe in NFA diagram, which is final state here? Q1 is final states. So in DFA transition table, which state having Q1, that all are final state. I already told that NFA, DFA, only one initial state, but it contains multiple final states, right? So here Q1 is final state. So in this Q1 is final state. Here Q0 Q1 is also final states. So here star represent final state, right? So this is the transition diagram of DFAs. Total how many states we obtain? Q0 Q1. Q0 Q1 is considered as one state. So Q0 Q1 Q0 comma Q1 considered as one state, right? So Q0 of 0 it moves Q0 comma Q1. Q0 of 0 it moves to Q0 comma Q1, right? Next, Q0 of 1 it moves to Q1. Q0 of 1 it moves to Q1, right? Next, Q1 of 0 null state, there is no move, right? Next, Q1 of 1 is Q0 comma Q1. Q1 of 1 is Q0 comma Q1. 1 is Q0 comma Q1. Next, Q0 Q1 of 0 is Q0 comma Q1. Next, Q0 Q1 of 1 is Q0 comma Q1, right? So this is the DFA transition diagram for below given NFA. Okay, these are the examples from conversion from NFA to DFA.